and welcome to another video lesson. We are going to be talking about comparing rational numbers today, lesson 5.5. Go ahead and fill in the table of contents.
We're on page 60, so you can fill that in. You're going to need your one little half sheet of note paper that you got in class. All we're going to do is tack it into page 60. So we've been talking about how to find terminating and repeating decimals when we're given fractions. Today, we're going to use that when we are comparing and ordering rational numbers. We might see that come up again today. The two biggest things that we need to know for this lesson and this topic is that we can use the number line as a visual to help us compare and to order them from least to greatest, or greatest to least. It'll usually be least to greatest as the directions will give us today. So the second thing that you have to remember when you're comparing or ordering is that you have to compare and order in the same form. So the rational numbers must be all fractions or all decimals. We did this before when we were comparing fractions, percents, and decimals. We needed them to be either all decimals, all fractions, or all percents. So for this lesson, we need them to either all be decimals or all be fractions. So I have this zoomable number line. I showed you this before, and I'm going to talk about it again because we can zoom in to see what happens on the number line as we deal with very small pieces between whole numbers. So we have here 0 and 1, and I've zoomed in enough so that we can see on the positive side of the number line that the numbers will increase by 1/10. So 0.1, 0.2, 0.3, all the way up to 0.9, and then 1 will be the whole number. So you'll notice that the digits in the tens place is getting higher as you move to the right in the positive realm of the number line. If I go to the direct opposite, this is from 0 to 1. Notice the tens place goes from the 0 to 1/10. Just like with whole numbers, the digits 1, 2, 3, 4, 5, 6, and so on, all the way up to 1, get bigger. So 1/10, negative 1/10 is closer to 0 than negative 2/10. So you really have to understand how the negative side of the number line works when we're dealing with small numbers. And again, this is just a piece of the number line. Maybe you're comparing two numbers that are between 3, negative 3, and negative 4. So here's negative 3, here's negative 4. You might have hundredths in the mix as well. So halfway between these hash marks is the hundredth. So let me show you what I mean. If this is negative 3.1 and you want to know where negative 3.15 is, it's right in between, and you can think about it as 10 and 20, and 15 is halfway in between. But you have to make sure that the numbers, the digits, are getting bigger as you move away from 0. Again, remembering that as you move farther away from 0 in the negative side of the number line, you get smaller and smaller and smaller. So if you're comparing, this will be my last tip, two negative numbers, the same thing applies for when they were just whole integers. If you have negative 3.8 compared to negative 3.9, 3.9 is to the left, 3.8 is to the right, and the farther you are to the right, you're closer to that 0 when you're dealing with two negative numbers. So your examples are all below that box. There's 6 of them that we're going to do today. I would encourage you to go to that web-based number line and explore going, zooming in, especially if you're having a hard time visualizing the number lines as we move on. So I'm going to start off easy with example 1. We are comparing a positive number and a negative number, just like we did before. If there is a positive number and a negative number, the positive number always wins. So you can't just look at the 1.2 and the 0.8 and look at the digits. You have to first look at whether they're positive or negative. Because the 0.8 or 8/10 is positive, it is the bigger digit. So we use our greater than, our less than symbol, so it's open towards that bigger number. If you wanted to use the number line, I would just put a -1, 0, and 1 on a number line. Very simple, very small, it's only a piece of it. And our -1.2 would be somewhere over here, and our positive 8/10 will be somewhere over here. Obviously, the bigger number is the positive one. Now, example 2 gets into the newer concept of this lesson, comparing 2 negative decimals. So, if we were to draw a portion of our number line to help us visualize this, these 2 numbers are both starting with -1. So that tells me I am somewhere in between -1 and -2. I'm not just -1, I'm -1 point something, 0.25, or -1.40. So I'm going to be looking at the digits that are in between those 2 whole numbers. I notice the next place value place has 2 different digits. That's great because I can just create a number line with the tenths places marked. So halfway in between is going to be -1.5. And now we can estimate where these 2 decimals go. -1.25 is somewhere in this area. Actually, it's right halfway in between. And -1.4 is going to be right before the -1.5. Now, if estimating like that is not good enough, you can literally put a number line together where you're comparing -1.5 to -1. And you can literally put all of the numbers in here. -3. So I have -1 and I have -1.5. It's like I took this section and increased and zoomed in even more. So I have a hash mark that represents each tenth. And notice I'm moving always bigger digits as I move to the left. So -1.1, then -1.2, -1.3, -1.4, and then -1.5. Do not reverse it. A lot of kids are used to the positive side of the number line, so to reverse it, sometimes you forget. So please make sure you're remembering that negative numbers, the digits increase as you go farther away from 0, which means smaller number. So now we can even more specifically say, okay, -1.4 is here, and -1.25 is going to be in between -1.2 and -1.3. Either one of these number lines could help you compare, at the end of the day, which one's closer to 0, which point is farther to the right, and that is -1.25. So we have another less than symbol. Side note, if you're wondering where to put these number lines, hopefully you have some space around your note sheet. Obviously, if you need more space, you can always go onto your notebook page. Okay, example 3, we have two negative fractions. Now, because they're both fractions, we can leave them fractions. If you are more comfortable converting them to decimals, go for it. You're going to have to divide and annex zeros like we did in the previous lesson. But I'm going to make sure, if I'm dealing with my fractions, that I have common denominators. So if you are only comparing two and they're both fractions, make sure the denominators are the same. So I can change this -3/8 to -6/16. So now I'm comparing 6/16 to 5/16. And again, I can make a number line where I am dealing with 16ths. So here is 0, here is -1. I'm going to have halfway in between is going to be 8/16. And remember, it goes in order. So this is 1/16, 2, 3, 4, 5, 6, 7. Not exact, but those hash marks represent 16ths. So again, 1/16, -2/16, -3/16, -4/16. Here's -5, and here's -6. They are very, very close to each other on the number line, but by 1/16, the 5/16 number is closer to 0. So again, we have the less than symbol. For example 4, I am going to have to convert my fraction to a decimal. It's easier to compare two decimals, I think, than two fractions. We just did this in the previous lesson, so we are all equipped to do that. And I'm going to take 8 and divide it by 15. I'm going to have to annex zeros. And 15 times 5 is 75. When I subtract, I get a 5. I'm going to annex another 0. I'm dealing with 50. 15 times 3 is 45, so that will be my best number to work with. When I subtract, I notice I'm getting another 5. That's good news. I'm going to then need another 3 and another 45, and lo and behold, I'm seeing a pattern. So I can stop. The 3 is going to repeat. So this number will change to -0 and 5, 3 with a line over it. Now I'm just going to get rid of my work so I can think about the number line now and which one of these guys is closer to 0. If I have a number line, I'm going to be looking at where -0 and 51/100ths is, and that digit, that decimal, is very close to -51/100ths. To the left is going to be 0 and 52/100ths, and right after that will be -53/100ths. -53/100ths is going to be farther away from 0 than -51/100ths. Therefore, this first number is the bigger number. Now the last thing that we're going to do is order a bunch of numbers from least to greatest. Same ideas apply, but we have to have them all into the same form. So I'm going to recognize that we have -2.46, already a decimal. -2 and 22/25, I need to convert to a decimal form. Remember back in, a previous chapter, I don't remember which number, we talked about how 10 is your friend and so is 100. So we can convert this easily into 100. So this is going to be equal to -2 over something over 100. 22/25ths, if we multiply by 4/4, will give us 88/100. All that to say, we are dealing with the decimal, -2.88. The last one hopefully is easy for you to do because 1/10 as a decimal is just simply 1/10. I'm going to actually put the 10 there, so 10 hundredths, so that I have 2 digits in each decimal to the right of the decimal. Now, if you are okay with this concept that the smaller negative digit is closer to 0, you can simply look and compare and pick out the smallest number and the biggest number very easily just by looking at the digits. You don't have to use a number line, but for many people, the number line is a great strategy. So I'm going to do both. So number line, we are in the -2 world. So we have -2 over here, -3 over here. Halfway in between will be -2.5. And now we can begin to put our numbers in. -2.1 is going to be very close, but a little bit beyond -2. -4.6 is going to be closer to -2.5, but a little bit before it. And -2.8 is going to be almost close to that -3. So visually now we know which one is smallest. It's the 2.88, which was our mixed number. So in my list, I'm actually going to go back and use the original form. But sometimes on multiple choice questions, you'll see the mixed number, not -2.88. The middle guy was at -2.46. That was the original form. And then the biggest negative is that mixed number 2 and 1/10. So this is the correct order from least to greatest with the number line, and when you're just comparing the 4, the 8, and the 1, to do that without the number line. Last one, similar directions, order from least to greatest. We're going to convert what we need to convert first. This one, we have -3 1/4. If you remember from our chapter on fractions and percents and decimals, that is equal to -3.25. We have a -2.2. I'm going to add a 0 so they all have the same number place value places. I have a positive 1.7. I'm going to add a 0. And then I have a -1.7. 7/10 is the same as 0.7. This one's very easy to do as far as ordering them because all of the whole numbers are different. So number line, we can just stick the whole numbers on our number line. We need a 1, we need a 0, -1, -2, and -3. So let's estimate where these numbers are going to be. -3.25 is a little bit beyond -3. -2.2 is going to be a little bit beyond -2. Positive 1.7 is a little bit beyond 1. -1.7 is in between -1 and -2. You can estimate. All you need to know is which one's bigger than the other one. So now we have -3 is our smallest negative. Then we have -2. And sorry, I'm going to change this to the form of a mixed number. There we go. Then we have our -1 and 7/10. Finally, we have our positive number, which is the biggest. So there you have it. We will order rational numbers and compare rational numbers in the class tomorrow. I look forward to seeing you then. Have a great night.